Bismillahirrahmanirrahim. Assalamu alaikum, dear students. So far, we have learned that integration and differentiation are inverse process of each other. Thus, for any function, if we know whose derivative it is, we can easily find its integral. Let us first talk about some trigonometric functions. Differentiation of sin x is equal to cos of x. That means antiderivative of cosine of x is equal to sine of x, or integration of cos x is equal to sine x plus constant of integration c. Similarly, differentiation of cos x is equal to minus sine x. That means integration of sine x is equal to minus cos x. Integration of sine x is equal to minus cos x plus c. Differentiation of tan x is equal to secant square x. That means integration of secant square x is equal to tan x plus c. Differentiation of cot x is equal to minus cosecant square x. That means integration of cosecant square x is equal to cot x. Differentiation of secant x is equal to secant x tan x. That implies integration of secant x tan x is equal to secant x plus c. Differentiation of cosecant x is equal to minus cosecant x cot x. That implies integration of cosecant x cot x is equal to minus times cosecant x plus c. Now let us prove integral of x raised power n dx is equal to x raised power n plus 1 divided by n plus 1 plus integration constant c, where n is not equal to minus 1. Here we have function x raised power n plus 1 divided by n plus 1, where n is not equal to minus 1. In case n is equal to minus 1, then we get minus 1 plus 1, that is equal to 0. And if we have 0 in denominator, then the function becomes non-defined. Now we differentiate this function. Here, this n plus 1 is constant, so we can write 1 by n plus 1 derivative of x raised power n plus 1. Now we differentiate this x raised power n plus 1 and we get it is 1 by n plus 1, and differentiation of x raised power n plus 1 is n plus 1 x raised power n plus 1 minus 1, which is further equal to, now here n plus 1 divided by n plus 1, that is equal to 1, and here we get x raised power n plus 1 minus 1, plus 1 minus 1 cancels, so we get x raised power n. Now differentiation of x raised power n plus 1 divided by n plus 1 is equal to x raised power n. That means antiderivative of x raised power n is equal to x raised power n plus 1 divided by n plus 1. So we can write antiderivative or integral of x raised power n is equal to x raised power n plus 1 divided by n plus 1, and we have to write here the constant of integration c. Now that is the result. Thus we can write integration of x raised power n is equal to x raised power n plus 1 divided by n plus 1 plus integration constant c, where n is not equal to minus 1. Now let us take some examples based on this result. If we want to find integral of x raised power 3 dx, that is equal to x raised power 3 plus 1 divided by 3 plus 1 plus constant of integration c, that is further equal to x raised power 4 divided by 4 plus c. Now let's take one more example. If we have integral of 1 by x square dx, we can write it like this: integral of x raised power minus 2 dx, which is further equal to x raised power minus 2 plus 1 divided by minus 2 plus 1 plus constant of integration c, which is further equal to x raised power minus 1 by minus 1 plus c, or that is equal to minus times 1 by x plus c. So that completes this question. Now, if you have functions of this type where in numerator you have derivative of denominator, then integral of those functions is equal to log of mod of denominator. Now let us take a function y is equal to log of f of x. If we differentiate this function, we get dy by dx is equal to 1 by f of x into f dash x, or d by dx y is equal to log of fx. So we write log of f of x is equal to f dash x divided by f of x. Now that means derivative of log of f of x is equal to f dash x divided by f of x, which means antiderivative of f dash x divided by f of x is equal to log of f of x. So we can write antiderivative or integral of f dash of x divided by f of x dx is equal to log of f of x plus c, that is constant of integration. So integration of f dash of x divided by fx is equal to log of f of x plus c, that is log of denominator plus c. Since a logarithm of negative number is not defined, so to make it more appropriate, we can write log of mod of fx plus c. Thus, if we have integral of f dash x divided by fx dx, that is equal to log of mod of fx plus c. Now let us take an example. 1 by x In this case, we have x in denominator, and in numerator we have derivative of x, that is 1. So we can write this is equal to log of mod of denominator, that is x, plus integration constant c. Whenever we have derivative of denominator in numerator, at that time we can write this is equal to log of the denominator. So let's take one more example. Now look here, in this case we have in denominator we have x square, and in numerator we have 2x, that is derivative of x square. So here we can write this is equal to log of mod of denominator, that is x square, plus integration constant c. In this case the modulus is not required because x square is always positive, so we can simply write it like log of x square plus c. That completes the result. Let us take one more example. We have integration of tan x, that is equal to integral of sin x divided by cos x. We know that differentiation of cosine of x is equal to minus sin x. So we can write minus times minus sin x divided by cos x dx. Now in numerator we have minus sin x, and that is derivative of denominator. So we can write this is equal to minus times log of mod of denominator, that is cos of x plus c. Since we know that log of 1 by x is equal to minus times log of x, therefore we can write this as log of 1 by mod of cos x. Also 1 by cos x is equal to secant of x, so we can write log of mod of secant x plus c. That completes the result. So thus integration of tan x is equal to log of secant of x plus c. Now in my next lecture we will do some questions on what we have learned so far. Till then, take care of yourself. Thank you.